So, boys and girls, say goodbye to topic one. Topic one was our Python basics, our software development with all of our lovely diagrams, and our data types. We are moving on. We are into topic two, and it's called the object-orientated paradigm. Now, it sounds really convoluted and complicated, and even when this is just a theoretical lesson, we're just going to go through lots of theory, lots of terms, and it's probably going to make only half sense until we start using it. And I feel like if you get a penny that drops during the practical things, you're going to love OOP. In fact, I love OOP because it makes clean code, it is easy to write, and it makes your programs just look so nice. Before I talk to you about what the hell it is, bring your brain back to your Hangman programs. Tarek, how many lines of code did you have?
957.
How? Hayden, how many lines of code did you have? Adrian?
Yeah, around 250.
250, okay. Alexis? 160. Tommy? Okay, last one, Jensen. No idea. I love that number. So, boys and girls, I reckon I could recreate. So actually, I should rewind. My Hangman game is probably about 200 lines of code. Maybe a little bit less. I reckon I could rewrite my Hangman game using this object-orientated paradigm, and I could get it down to probably 30 lines of code.
What about his?
30 in the main file. There would be other files with more code, and that is the trick. Okay, so everybody, we have been doing what's called procedural programming. Welcome to the world of object-orientated paradigm, or OOP for short. So OOP programming has been around for a very, very long time. And it's the idea that we represent real-world objects in our code. So if you have to remember a person, you make an object called a person, and you give them a name, you give them an age, you give them a gender, you give them functions like move around, heart beats, you eat food, all that kind of stuff. And all that is self-contained in a person. You also can make a class about a car, and that car has a name and a brand and a year and a color. Maybe it has actions like drive around, turn the headlights on, indicate left, indicate right. It has data and actions in one container. The other thing we can do, if you look at this lovely little diagram there, boys and girls, at the tippity top we have an automobile. Now, that's a really generic concept that we can expand down into different types of cars. We have a car on the right and a bus on the left. And even those are fairly generic, so we can go further down to Ford, BMW. Could we go further than that, do you think? How far could we go? What could go under Ford, do you reckon?
Go to the year and go to quality. Go to like.
Yeah.
You could go
absolutely.
You like, is it
Ooh, yeah. Like a form factor sort of thing. Really nice. But boys and girls, can I separate this? Those are trees over there on the board. This is not a tree. This is just me representing an idea of OOP program. So everything is organized as data and code. And it's all separated. And it's really good because the code you write is in a lovely little box, and Brody tests the crap out to make sure it doesn't break or fall apart. And if I use his lovely box of code, it should just work straight away. Yeah? How many of you here at some point in your coding life wrote os.system.cls? In other words, you cleared the terminal. That code was written by someone else in an object, and that object was called OS. And you were literally using someone else's code. You were saying, I want to clear the screen. And some guy or gal or whatever, somewhere in the world has written that code to do it for you. So you've already used OOP, you just didn't know about it. To move on with our lives, if that still doesn't make sense, let me give you a bit of a real world example. Hands up if you've ever built or pulled apart or looked inside a computer. Like you've ripped the case open. Most people, most IST, yes. You should have put your hand up this stage. Now computers are great at representing like this OOP mentality Because if you rip open your computer, you will see lots of bits and pieces, won't you? And if you're like me and you don't organize your cables, mess of cables, spaghetti everywhere. But what you'll see is a giant green chip called the motherboard. And onto the motherboard, you plug in a bunch of things. You plug in your power supply, your CPU, your hard drive, your RAM, and your graphics card. Now, each one of these pieces has a job. What do you think the power supply is for, Sam? Got it in one. What do you reckon the CPU is for, Adrian?
It's the brain.
It is the brain. Spot on. Tarek, what's the SSD or the hard drive for?
It's consolidating your state drives.
What does it do?
It's not
Absolutely spot on. Zach, what about your RAM? What does that do for you? Absolutely spot on. And then graphics card, Brody, what does that do for you? Displays on the screen. So all of these pieces of hardware do their own job, don't they? In fact, if you plug them into a power supply and sort of turn them on somehow, they would probably work. Wouldn't be very useful because you wouldn't have everything plugged in and working, but all these pieces work by themselves. It's only when you put them together onto the motherboard that magic happens. And you've got a computer. Dobby, what happens if my CPU dies though? It's screwed. What can I do to fix it? Spot on. That's the other great thing about OOP programming. Your CPU dies, throw it away and go get a new one. And the other parts are still fine. Exactly right. Another great benefit of OOP programming. If part of your code sucks, broken, it's old, whatever, you throw it away and you get a new one. It's actually amazing. And the great thing is, if I try and turn on my computer and I notice that my hard drive is no longer saving files, I can sort of narrow down what the problem is, can't I? I go, if my hard drive's not saving, it's probably the hard drive. Again, I actually had that, but I'm not going to get into it today. So guys, if you look at this lovely little diagram, I know lots of theory, we're just going to try and smash this out. On the right-hand side is what you guys and gals and everyone in between has been doing since the dawn of this year. When you came in day one, you wrote print hello world, and then you added another line of code, another line of code, another line of code, and you ended up with Taryn's 975 lines of code. You've been procedurally programming. It's the idea that your program is organized into its functions. Okay? Here's my menu. Here is my easy game. Here's my medium game. Here's how I save scores. And it's really good for small things like Hangman. Make sense so far, everybody? You're literally just like adding lines of code to a file until you've got the program working. However, you end up with spaghetti code. Has anyone ever seen spaghetti code before? Let's have a look.
Yeah, that was pretty accurate.
So that's assembly code. I don't want that one. Nah. Nice. It's really just trying to find something that doesn't suck. No, see, that's good code. I don't want good code. I want crap code. Hey, that's pretty good. All right. Can anyone tell me what that does?
Yeah, mate. So what it's doing?
I can actually tell you right now, but I'm not going to. Can anyone tell me what that code does? No.
Doesn't tell you.
Yeah, it's just like checking for invalid values. Ben, what do you reckon? Checking if it's already. Bingo, it's checking if it's already. So, boys and girls, that's spaghetti code. It is code that looks like garbage, and you keep adding more ifs and more while loops and all that crap, and all of a sudden, no one can read it, not even the person who wrote it. Okay? And that's when we go, this code sucks. Let's not procedurally code anymore. Let's use OOP. And the idea is we start organizing things into these lovely little boxes. You put the code inside the box with the data. And that's why I said I reckon I could do Hangman in 30 or 40 lines of code. Because I could with using OOP programming. Isn't that right, Val? And the great thing about OOP is when we start getting into these more complex programs, OOP actually becomes a lot better. So, really, really wanted to find a spot where I could put these concepts in a logical fashion. I could not. So welcome to other concepts that I'm going to just throw at you. Okay. So we talked about OOP for a fair chunk. This one is related to OOP, but I just don't like where I put it. Top down, bottom. Do we start with the problem and break it up into pieces, getting smaller and smaller and smaller to solve our problem? Or do we start with small pieces and build them all up together till we have a solution to the problem? Exactly. That is top down, bottom up. Moving along, the facade pattern. How many people here have used Google? Yeah? One or two? One? Yeah? No? Jensen has... How is that? Guys and gals, I would like to estimate that Google probably has like 1 billion lines of code behind it. And like petabytes worth of data. No, just Google, just the search engine, nothing else. Okay?
2 million lines of code.
2 million. All right. But look at this. Like, this is the old version of Google when I was growing up. This is hiding so much complexity, and all it gives you is a box, and you hit search, and there you go. There's your answer. Google are the masters of hiding complexity, and that is what the facade pattern is, guys and girls. So taking something ultra complex and boiling it down to a single button that the user clicks on. Another great example, if you've ever used a Mac computer or Spotify or something, as you start searching, it's already producing search results like right away. There is so much work going on in the background, but all you get is a search box. So it keeps it quite simple. So this is the facade pattern. Hide complex code behind a simple interface. The next one, agility, being able to essentially adapt when there are problems. So if a client comes up to you and says, I changed my mind, I want the whole thing to be blue. You go, oh crap, now I need to go back to the drawing board and change everything to blue. That's fine, but then they come up to you and say, well, you know how we said we want everything printed on paper? Well, we actually wanted to generate emails automatically with attachments that we can send to all of our clients. And you go, oh, okay. OOP allows you to really quickly adapt to those problems. There's changing needs, those things that come up. Even laws can change. Like now we have GST, now we have different types of taxes. Well, the agility of OOP allows us to make really quick changes. Guys and gals, I'm going to pause there because we've got a few activities. Can I get you to find any slide from this one with a white heading and summarize some notes in your book, please?